In this video, we are going to start the state-space analysis. Up to now, we used to take the transfer function techniques to analyze any systems. So here, from these classes, we are going to start state-space analysis used to analyze this system. What is the state-space analysis? State-space analysis, it is to give the future behavior of the systems based on the present input and past history of the system. What is nothing but the past history? Past history is nothing but is describe the state variable. It is provided for the initial value or initial state of the condition. What is the initial value of condition? Example, if you consider we are having the electrical circuits, here resistor, inductors and capacitor. We are having the circuits. So we know that the capacitor is the energy storage element. So it's give the initial value to the system. So it is called as the initial conditions. It's give the positive history of the system. But it having the resistor element do not have the any state-space variable. It is output is only depending on the present input of the system. So it is not have the any memory element. So it is not having the any initial state of the condition. So the circuit is called resistive circuit is called memoryless system. Consider now the number of state variable which is depending on the number of the memory element. We know that number of the memory element is the inductors and capacitor is the memory element. So number of the state variable depending on the number of the capacitor inductor present in the circuit. So it is number of state variable present in the circuit is depending on the number of energy storage element. If consider if they are given for the differential equation, then number of state variable equal to number of order of the system. Order of the different example, if d squared y divided by dt squared plus dy divided by dt equal to plus y equal to u. So in this number of the state variable is order of the value is number of state variable. If additionally we have d cube y divided by dt cube is order of number of state variables in 3. It is depending on the order of the differential equations. First of all, before getting into the subject of state-space analysis, we will know some basic idea about this state-space analysis. First of all, what does mean by state and state variable? What is mean by state vector? We want to know that the state is a group of variable which is summarize the past history of system in order to predict the future value. That means that if we are there in the present state, we can based on that it is a state. State is we can have the past history of the state. They can give it to the present state that will predict the future behavior of the system. State variable is nothing but it is small set of variables that determine the state variable. We know that already we have discussed state variables means number of energy storage present in the circuit is called state variable. Example, inductor and capacitor is the energy storage element. It is called as state variable. State vector, it is the vector which contains the state variable of element. That means that it's all the state variable have example variable is the inductor capacitor. Inductors having its energy storing in the current and capacitor storing the voltage. It's contained the form of vector. It is called as a state vector. Next, advantage of and disadvantage of state vector. We know that analysis is done using for state-space analysis. It is done by considering the initial condition. Yes, of course. We are using for different kind of techniques. We can analyze the system using the transfer function, but there need for the different kind of conditions required. But in this case, only we can record for the analysis of initial state of the condition. And another more advantage is more accurate than the transfer function. and it analyzes the multi-input and multi-output system is made easy in compared to the transfer function model. Transfer function model is multi-input multi-output system, very complicated to get the result compared to the state-based analysis model. And also it's give the information about the controllability and observability. We can better compare with the state-based analysis. It is applicable for all dynamic system. Example for all dynamic system means linear, non-linear, time variant, time invariant systems is also applicable. We can analyze the system behaviors for the state-based within the state-based model application. Disadvantage is that the system is complex techniques. It is a very complex techniques, but process is very easy. In processing space is very easy. It is the main disadvantages. Another disadvantage is you can take it for the more computational and required to execute the code. It is all the disadvantages. State-based analysis model we can represent in state equation is x dot equal to ax plus bu, and output equation we can mention as cx plus du. The x is a differential vector. That is we can mention as the differential state vector, and y is the output vector. Generally, we can call it as this is the state equations. We can call it as a state equation, and this is the equation for output equation. We can call output equation. This x dot in A is B is a state equation, or we can call it as a dynamic equation. We can call that. It is A is indicate that it is a state matrix. So indicate the state matrix, and x is the state variables, and B is the input variables and input matrix, and U is the input variables. We can apply for the input variable, and C is the output matrix, and D is the transition matrix. Here we can see about this diagram multi-input multi-output system. We are applying for the input the multi-input variable. We can get it the output of multi-output variable P. But this is output is only depending on the present input, and past history of the value is predict the future output. So that the state variables is it is the inductance capacitance value of the state variable is predict the future behavior of the system. It is general standard form of the state model. Ax dot equal to ax plus bu, y equal to cx plus du. Coming class, state model. Yearly class we know the state model analysis, state-based analysis. We know that it's predict the future behavior of the system based on the present input, past history of the system. We have to find out the state. So we have to analyze the state-based analysis. So state model is based on that they give for the equation, that is a state model equation. We having the two equation. One is x dot equal to ax plus bu. This is state equation or dynamic equation we can call. Another equation is there. It is a y it is output equation, y equal to cx plus du. We have to find out this. This is a state model. So from this unit, what we are going to do is we have the four different form of the problems will be there. They are giving to the differential equations. Example 3y double dot plus 4 double dot plus 2y dot plus 6y equal to u. It is a differential form of the equation. We have to find out the state model equation from this. And another one they are giving for the transfer function, that is the C of s divided by or output divided by input equal to the transfer function is given. We have to find out the state model equations, and we have the state model signal flow graph. Sometimes they give for signal flow graphs. They give. We have to find out the state model equation. We have to find it. Next for the state model of electrical network, they given the problem is given, the electrical circuits is given, that they can present an inductance, capacitance, resistance they will present. We have to find out the state model equation using for the Kirchhoff voltage law or current law you can using. We have to find out. Upcoming classes we are going to see about the different each way of the problem. We will be one by one we are going to see.